Competitive programming models get better the more times you let them try. Generate 1,000 candidate solutions, keep the ones that pass hidden tests, that is, pass at K, but there is a wall. When a problem is hard enough that a single correct solution is nearly impossible to sample, no amount of extra tries helps. The search space is just too large. A 2026 paper from FAIR at Meta called Decomprl makes a different bet. Do not sample harder. Decompose. It cuts GPU token cost by about 50 times and solves problems standard training cannot reach. Here's how. Here's why both standard strategies stall. First, repeated sampling. GPU cost grows linearly with the number of attempts, but performance grows only logarithmically, diminishing returns. Second, reinforcement learning. RL sharpens the policy on one solution mode, which improves pass at 1 but destroys the diversity you need for pass at K. Both bottom out when the per attempt success rate is near 0. No amount of sampling or gradient signal overcomes a search space too large to hit by luck. Decomprl's bet, make each piece easy enough that its success rate is high, then let recombination do the combinatorial search. So, the paper trains two cooperative policies. A decomposition policy breaks the problem into n function signatures with docstrings. An implementation policy writes k equals 8 implementations of each function, in parallel, independently. Here is the asymmetry. N times k model forwards yield k to the power of n candidate programs. 6 functions, 8 implementations each, that is 48 forwards but 262,000 recombinations. Candidate count scales polynomially in k. Inference cost scales linearly. And verification, running hidden unit tests, is a cheap CPU operation. Generation is the expensive GPU operation. Recombination shifts the bottleneck exactly where the paper wants it. But does the modular format help on its own? No. The paper isolates this cleanly. Prompted hierarchical inference without RL underperforms standard. On Quen 2.57b, standard scores 14% pass at 1. Hierarchical without RL drops to 11. The modular scaffold is a tax, not a free win. RL is what flips it. Decomprl lifts Quen to 18%. And on Code World Model 32b, hierarchical jumps from 11.9 to 27.8 once you add the RL training. The gain is the objective and the cooperative two-policy training, not the scaffold. Now the honest headline. Decomprl only wins at high token budgets. At 5,000 tokens, it loses to GRPO. At 10,000, it still loses. The crossover lands around 50,000 tokens per problem. Above that, Decomprl pulls ahead, reaching 48% at 500,000 tokens versus 46 for the best baseline. This is the format tax. Hierarchical inference wastes single sample precision, which only pays off once the recombination budget is large enough to exploit diversity. Decomprl is a high-budget search policy, not a pass-at-one improver. Picture the shift. Start with one tangled monolith, a single program the model has to nail all at once, every piece coupled to every other. One wrong line sinks the whole attempt. Now break it into clean modular blocks, each function small enough to solve reliably, then recombine them. 48 forwards explode into hundreds of thousands of candidate programs, each a different assembly of working parts. That combinatorial search, offloaded to cheap CPU unit tests, is what reaches problems no single-shot policy can touch, and the cost cut is the most citable result. At matched evaluation count, 512 candidates per problem, standard sampling burns about 198,000 generated tokens. Decomprl burns about 4,000, roughly a 50 times GPU token reduction. Execution cost is identical. The same 512 programs are unit tested either way. The GPU share of total work drops from 15% for standard to 0.4% for Decomprl. Wall clock savings scale with how GPU bound your cluster is, up to 3.6 times faster. So the practical lessons. Do not add more compute or a bigger model when the base policy cannot reach the answer. Change what is being searched. Decompose into independently solvable modules and let recombination explore. Use the log mean xbay objective, a smooth knob between mean and max, to avoid the gradient saturation that kills pure pass at K training. And be honest about scope. Decomprl degrades the Llama 3.18b and loses at low budgets. It is an explorer for the high budget regime, not a universal fine-tune. Reinforcement learning that expands the reachable solution space instead of sharpening pass at 1. 2 cooperative policies, decomposition and implementation. 48 forwards, 262,000 recombinations, a 50 times GPU token cut. The paper is Decomprl from FAIR at Meta. The honest scope, it only wins beyond 100,000 tokens per problem. But the core finding travels. When the search space is too large to sample, do not sample harder, decompose. Subscribe for the next breakdown.